Hello friends, good morning.
Good morning, sir.
Okay.
Good morning, sir.
Okay, we will start now. Already we have late for 10 minutes. In last lecture, we have seen Pelton wheel turbine. Okay, so the turbines are nothing but power producing devices which produce power. In our syllabus, uh, three types of turbines are there. So first one is the Pelton wheel turbine, second one is the Francis turbine, and third one is the Kaplan turbine. Okay, so in last lecture or previous lecture we have seen how Pelton turbine works. Then we have seen how hydroelectric the structure of hydroelectric power plant. Okay, so
Sir, waiting room check करायचं.
waiting room. No, nobody is there. नाही कोण नाही इथं.
Okay, sir.
कोणाचा कॉल आलता काय वेटिंग मध्ये आम्ही. Okay, so this is the schematic diagram of a Pelton turbine where runner is mounted on a shaft and with the water jet which consists only kinetic energy. So it acts tangentially to that turbine or strike tangentially to the turbine. So the Pelton wheel turbines are tangential flow turbine, and the energy available at the turbine is in the form of kinetic energy. So we call it as impulse turbine. Okay. Now next one. Next one is the Francis turbine. Francis turbine is also very important, and this turbine is as compared to the Pelton turbine and Kaplan turbine, the Francis turbine is having more efficiency. Now this turbine works at a moderate head. It means near about 250 meters to 300 meters. These turbines can be used, and for medium water flow, we can use these turbines. Okay, so the Francis turbines are very important, and the design, but the design of that turbine is somewhat complicated. It means when, if you observe here, this one is the demo of a Francis turbine, very small demo. So this one is here. That blue color is a casing of the turbine. That yellow color is showing or shown here the arrangement or the mechanism to adjust the guide vanes. Then at middle, the shaft is provided. The shaft is coupled with the shaft of a generator. So this one is generator. This is not motor. It looks like motor, but this one is generator. So as the shaft rotates, the generator produces electricity. Now this one is the diagram of a Francis turbine. Okay. But this diagram, you consider you are seeing or you are going to observe this diagram from the top. Then and then only you can understand this. Okay. After this, I will explain. I will show you video also, so it will more clear in the video instead of here. Okay. So in construction, same construction like here, near about same construction of centrifugal pump, but here in water flow in opposite direction. Now this one is the penstock, or it is also called spiral casing, or it is also called scroll casing. Okay, so this one is the casing which is at outside. So these turbines are very bigger turbines which are generally mounted under the ground. Okay, so and or at the level of ground, and water flow takes place through that penstock. So This is the scroll casing. If you observe, the area of scroll casing goes on increasing, and at inner side of that casing, openings are provided. So here openings are available. It means water can flow towards runner through that veins. Okay. So these veins are the guide veins. Now, what is the function of guide veins? The function of guide veins is to guide the water towards the vein of runner. Okay, in particular direction. Yeah. Okay. So at that time we can extract maximum amount of energy from the water. Our motto is to convert maximum amount of hydraulic energy into the mechanical energy. Okay. So from these all gates, water can flow towards the runner. These gates are movable. These gates are movable. When the water level is low, it will move in such a way that the water should flow towards all of this casing. म्हणजे जर पाणी कमी आलं तर इथलं पाणी फक्त इथूनच पडू नये आतमध्ये, म्हणून हे काय होतात, गेट थोडेसे क्लोज होतात, जेणेकरून इथून थोडंच पाणी पडावं आणि बाकीचं पाणी जसंच्या तसं सर्व बाजूंनी पाणी पडलं पाहिजे. ओके. It is the guide vanes are mainly used. Main purpose of the guide vanes that to regulate the flow all over the runner in unique or in same amount. Okay. Now this middle one is the runner. This one is actually moving part, or this one is actual turbine. Okay. If you observe here, you cannot get shape of the turbine here. The turbine is like that. Okay, and vanes are mounted here. I will show you video at that time, you will get it. Okay, and water enters from the guide vanes here, from here, and leaves from the bottom. Okay, and this one is the draft tube here. See, draft tube. Draft tube is fitted here. So if you observe here, the water enters into the turbine radially. Okay, water enters into the turbine radially and leaves axially. It means this one is mixed type flow turbine. In Pelton wheel, the flow is tangential, so this one is the tangential flow turbine. And now here, if the flow is radial, enters radial and leaves axial, so such turbines are mixed type flow turbine. Okay, when water enters here, at that time, on one of the side of the vane is like that. On one side of vane, high pressure is created of water, and on another side, low pressure is created. Due to that, from high pressure side, the force is applied. Due to that force, this vane start moving. Okay, when the runners start moving, now we will see this one is the draft tube and tail rest. Now we will see working. When water enters from the penstock, it moves around the guide vanes and enters equally from all the passage of guide vanes. Then it enters to the runner radially. And then after working, when runner take out energy, it means ज्या वेळेला रनर रोटेट व्हायला चालू होतो, याचा अर्थ कशामुळे रोटेट झाला, त्या पाण्यामध्ये असणारी जी एनर्जी आहे त्याच्यामुळे. ओके, So due to that, runners start rotating. It means hydraulic energy converted into the mechanical energy. But due to extraction of energy, the pressure of water decreases below atmospheric pressure. So to increase the pressure, we have to use this draft tube. If you observe draft tube, the function of draft tube is to increase the pressure, if you observe the construction of draft tube, the area of draft tube goes on increasing. If the area goes on increasing, it means the pressure of water will go on increasing. Okay, I will show you that scroll casing. So you all can imagine how bigger these turbines are. For that, I have to find out from network. So give me 1 minute.
सर डायग्राम काढायची का?
डायग्राम ना, हा काढायची की डायग्राम थोडीशी मोठी होईना, झूम होईना फिगर इमेज वरची, त्यासाठी मी थोडंसं पाहायला लावलं. ठीक आहे, राहू द्या, याही एवढीच दाखवतो मी तुम्हाला.
सर F11 ट्राय करा की सर
नाही त्याने
कीबोर्ड वरती.
नाही त्याने पण होईना, झूम करून पण बघितली मी, पण ठीक आहे, कामापुरती आहे आपल्या, म्हणजे आयडिया येण्यापुरती किती मोठा आहे होऊ शकतं ते. Now, are you able to see this?
Yes.
Yes.
Okay.
Yes.
So this one is the spiral casing. See, like this. So this is the spiral casing. So these are very bigger one. If you, I don't know whether you are observing or not. Here 2 or 3 persons are working here. तुमच्या मोबाईलवर दिसतंय का नाही बघा जरा, हे झूम होतंय का बघा. इथं 3 माणसं आहेत काम
Yes
करतात.
sir.
मग याच्यावरून तुम्ही अंदाज लावू शकता की हे टर्बाइन्स किती मोठे असू शकतात. ओके, सो या स्क्रोल केसिंग वरती चढण्यासाठी, इकडून तिकडे जाण्यासाठी इथे जर बघितलं तर तुम्हाला शिड्या दिसतील. शिड्यांचा वापर केलेला आहे. इथे एक शिडी आहे, इथे एक शिडी आहे. ओके, नाउ सो दिस स्क्रोल केसिंग इज ओपन हिअर. इथं ओपनिंग आहे त्या स्क्रोल केसिंगला. जसं आपलं गाडीचं टायर असतं, आतल्या बाजूने कसं मोकळं असतं किंवा ओपनिंग असतं त्याला, तशा प्रकारे या स्क्रोल केसिंगला ओपनिंग आहे. त्याच्या आतमध्ये हे गाईड व्हेन्स आहे. इथं पोर्ट्स दिसतात बघा तुम्हाला. Okay, so the guide vanes are like what we can say, ports, bigger ports, so that ports can be adjustable. Okay, so these are the Francis turbine, and here at middle runners are mounted. Now here in this diagram runner is not present, actually runner not installed here or up till, so here runner will mount. And when water flow takes place from this scroll casing or the spiral casing, it enters from all over. To the runner. या रनर वरती ती जाईल आणि व्हेन्स वरती स्ट्राईक झाल्यानंतर व्हेन्स त्याची एनर्जी एक्सट्रॅक्ट करून घेतील आणि तिथून हे वॉटर परत खाली पडेल. ओके, सो दिस इज द स्पायरल केस. ओके, समजलं तुम्हाला हे?
Yes, sir.
Yes, sir.
Okay, you do one thing. You please draw this diagram. Then I will show you video. When in video you will get more about the working. How it works.
सर वर्किंग रिपीट सांगा ना.
वर्किंग तुम्हाला आता मी व्हिडिओ मध्ये सांगतो.
हो चालेल.
हा, तुम्हाला तिथे जास्त व्यवस्थित समजेल इथल्यापेक्षा. So you draw this draw this diagram. So when you complete, let me know. You can put into the chat box. After I have provided link of PPTs, so someone can please check whether it is visible, or can you open?
सर असाइनमेंटला किती एमसीक्यूज लिहायचे?
असाइनमेंटला 30 लिहा. 30 MCQs. Okay.
येस सर.
Wait.
Ashwini? Ashwini Wagmare, why you are late?
Complete.
झालं?
Yes, sir.
Okay. We will wait for 1 minute for others. We will go for next, that is video of Francis Turbine. Okay, we will proceed for the next. Who do not get working of this turbine, they see here, and okay, is this visible now?
Yes, sir.
Okay, so I will start here. So all of you see here, so you will get working how it works in video. So this one is the Francis turbines, which is most effective or efficient turbine. So it will operate up to 400 meter here. So this part is the runner. This one is very important part, or we can call this as a turbine. Okay. So all remaining is all remaining components are required to run or to guide the water towards the runner. But the runner is exactly the main power extractor from the water. Okay. So if you observe here, these are the veins here. These are the veins. The water flow radially from that vein. Okay. And it is looking from bottom, it looks like this. And at middle, the hole is provided. So the water from the guide veins enters radially inside the turbine and leaves axially. मधोमध्य खाली पडतं. So this one is the one vein taken out. So this is one vein which taken out, and water will flow here. You can observe now. When the water flow, when water is flowing at that time, it creates high pressure on one side and low pressure on the another side. Due to that, from the high pressure side, the force is produced on the vein. So this force is due to pressure. So this one is the reaction pressure, we can say. So after that, when water इथून आत गेल्यानंतर पहिल्यांदा प्रेशर फोर्स मुळे त्याच्यावरती अप्लाय झाला. त्याच्यानंतर ते खाली पडताना जर इथे खाली बघितलं तुम्ही, if you observe here, so the veins having bucket shape. So when it water slides in downward direction, at that time also it applied pressure or the force due to kinetic energy here. So it produced impulse force. So two forces are produced on one side of the vein. So same process is going on for each and every one vein. प्रत्येक वेन वरती अशा प्रकारचा फोर्स एकाच डिरेक्शन मध्ये अप्लाय होतो. So due to that, the runner start moving or start rotating. So we get total force, that is reaction force and the impulse force, because we have kinetic energy as well as pressure energy. If you see in the Pelton turbine, we have only a kinetic energy. Okay. So here we have pressure energy as well as kinetic energy. So the shaft is connected at the center point of the turbine. So when turbine start rotating, so shaft also start rotating. This turbine is fitted into the here, and you can observe how the flows rotate the turbine and leaves the turbine. So here stay vanes and guide vanes are provided. So the purpose of this vanes is to provide constant flow towards you can observe here. इथे तुम्हाला दिसतंय का बघा, सगळ्या बाजूने फ्लो यावा तेवढाच प्रमाणात सगळ्या बाजूने फ्लो यावा टर्बाइन वरती, म्हणून त्या गाइड व्हेन्सची अशी अरेंजमेंट केलेली आहे. When the flow of water is low, at that time guide vanes are control the flow or reducing the flow, so it will rotate around all over the runner. These stay vanes are also provided here, which are not shown in the diagram, but stay vanes are small vanes which is near to the runner vanes. So when we extract energy, that is pressure energy from the water, so the pressure energy of water or pressure of water decreases below atmospheric pressure. So when we have to leave the water, we have to increase the pressure of water. To increase the pressure, draft tubes are used. You understood?
Yes, sir. Yes.
व्हिडिओ. कारण याचं काय माहित आहे का, ही जी डायग्राम आहे मी जी अगोदर दाखवली त्या डायग्राम वरून कळत नाही बऱ्याच जणांना. म्हणजे विद्यार्थी दरवर्षी जो क्वेश्चन विचारतात त्या डायग्राम वरून समजत नाही, पण व्हिडिओ पाहिली की समजतं. Okay, so once again I will play this video. If you have doubt, you please see it, observe it, and I am not going to explain now. Okay, once again we will play this video.
तर त्या व्हिडिओचा आवाज येत ना.
व्हिडिओचा नाही, व्हिडिओचा आवाज तुम्हाला येत नाही. You have to observe only. I will explain. मी बोलतो तो येतोय ना आवाज?
येस सर.
Yes, sir.
Yes.
Yes, sir.
I will explain once again, no problem. So this one is the runner of the Francis turbine. This one is very important and very efficient turbine nowadays as compared to three, that is Pelton turbine and Kaplan turbine. This Francis turbine having more efficiency. Water enters radially into this turbine and leaves axially. So this is mixed type flow turbine. When the water flow over the vane, it creates high pressure on one side of vane and low pressure on the another side. Due to that, it results in a force or the lift force from the high pressure side. When sorry, when water moves towards downward direction, it applies impulse force on the vanes. So the two forces acting on the vane, so due to that forces, the runner start rotating. So we have two forces here, that is reaction and impulse force. So due to that, when we to run that turbine, we require that kinetic energy and potential energy. See, so the both kinetic energy and pressure energy goes in down or reduces. That runner is connected to the shaft, and this shaft is coupled to the generator. Now this runner is mounted in the arrangement that we have seen in that image. So this one is the flow of water. When flow start, it will rotate the runner and then leaves. If you observe carefully, this one is very important. That is, the flow of water should be constant, should be same from all over. And to keep this constant flow, we use guide vanes and stay vanes. Stay vanes are near to the vanes of runner. Guide vanes can be movable. Guide vanes can be moved as to control the flow of water. So when the flow of water goes down, at that time, the vanes are closed. And when the flow is high, at that time, vanes goes on opening. ज्या वेळेला टर्बाइन मध्ये पाणी गेलेलं असतं त्यावेळेला त्याचा लो प्रेशर क्रिएट होतो. जो ऍटमॉस्फेरिक प्रेशर कमी असतो त्याच्यासाठी ड्राफ्ट ट्यूबचा यूज केलेला आहे. ड्राफ्ट ट्यूब ही अशी ट्यूब आहे ज्याचा एरिया इन्क्रीज होत जातो. Okay, so all of you get it?
Yes.
Okay, I know that you will not, many of the students, 90% students do not get how it works when they see this diagram. But when they are observing the videos, they will get it. So how much time we have? Is anybody having any doubt now?
No, sir.
तुम्हाला काही शंका असेल तर विचारा.
No, sir.
Okay. So we are here at the second last. So this one is the write-up on the PPT for the Francies turbine that we have already explained it here. So you can observe here, you will ask questions, sir. In a video, they will given 400 meter. Here they provide 250 meter. In another book, they provide 300 meter. So it may be vary. Okay, it is not mean that 300 means 300 perfectly. ओके, कळते तुम्हाला मी काय म्हणतोय? ओके, हे जे हेड आहे किंवा डिस्चार्ज आहे हा थोडाफार इकडे तिकडे असू शकतो प्रत्येक बुक मध्ये, कारण त्याला असं काही एवढं परफेक्ट लिमिट नाहीये, तेवढं ते प्रिसिजन असण्याची गरज पडत नाही, पण इन जनरली मीडियम लेवलला असू शकतो. So these are the parts, main component. There is scroll casing, we can call it as spiral casing, then guide mechanism, runner and shaft, and the draft tube that we have seen. So this is related to the Pelton turbine. Now next turbine is the Kaplan turbine. So in next lecture we are going to see this Kaplan turbine. So up to that, you please complete. Have you drawn diagrams in the assignment?
Yes, sir.
Okay, so only MCQs are remaining. I have uploaded a link for the PPTs. Someone asked me yesterday, or in last lecture, not yesterday. Yesterday I have not taken lecture.
सर असाइनमेंट कुठे आहेत का तिथं लिंकला, म्हणजे डायरीला?
हा, डायरीच्या लिंकलाच पीपीटी दिलेली आहे. आता एमसीक्यू मी अपलोड करायला लागलोय.
असाइनमेंट सर?
हा, असाइनमेंट मी सांगितले तुम्हाला
ते क्वेश्चन्स.
मी काय सांगितले क्वेश्चन, बट तिथे क्वेश्चन लिहू काय मी तिथे? ड्रॉ ऑल दी डायग्राम्स विथ नेम.
येस सर.
नाही तर मी काय करतो, वर्ड वरती लिहितो आणि ती एक लिंक अपलोड करून टाकतो, म्हणजे ते लीगल पण होईल ऍक्च्युली.
हो सर. हा सर, असाइनमेंटची म्हणजे पाठवा सर.
हा ठीक आहे, एक लिंक पाठवतो तिथं फॉर असाइनमेंट, आणि एमसीक्यू ची पण अपलोड करून पाठवतो. ओके, गिव्ह युअर अटेंडन्स. Today is the 19th. Roll number 1.
Present, sir.
2.
Present, sir.
3.
Present.
See, if you have network problem or issue, then you can raise your hand only. Okay, I will understood. Okay, it is also allowed. So raise your hand, and when I say okay, you can put down your hand. Okay, so where roll number 44, not now. When I call your roll number, at that time, like you have to raise your hand and then put down. Pratiksha, put down your hand. Roll number 3.
Present, sir.
4. Okay, 5. Roll number 5. Okay, 6.
Present, sir.
7.
Present, sir.
8.
Present, sir.
9. Roll number 9. Shruti.
Yes, sir.
Okay, 10. Roll number 10. Aniket Dhumar. Aniket. 11.
प्रेझेंट सर.
12.
प्रेझेंट सर.
13.
Present, sir.
14. 15.
Present, sir.
16. Roll number 16. 17. 17. 18.
Present, sir.
19. Roll number 19. 20, 20, 20 absent, 21,
Present.
22,
20 is present, sir.
22,
Present, sir.
23,
Present.
24,
Present, sir.
25,
Present,
25,
sir.
okay,
Present,
26,
sir.
26, 26, 27, 28,
Yes, sir.
29,
Present, sir.
30,
Yes, sir.
31, 31 absent, 32,
Yes, sir.
33,
Present, sir.
34, 35, 35, 36, 37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40,
Present, sir.
41,
Present, sir.
42,
Present, sir.
43,
Present, sir.
44,
Sir,
45,
41.
okay, 45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53, 53, 54, 54, absent, 55, 55, okay, 56,
Yes, sir.
Present,
57,
present, sir.
58, 59,
Present, sir.
59, 59 absent, 60,
Present, sir.
Yes, sir.
61,
Present, sir.
62,
Present, sir.
63,
Present, sir.
64, okay, I think up to 63. So I will call roll number of absent student. So roll number 10 is present, okay. 16, 19, 26,
Sir, 70 present.
okay, 17 I have marked. 19, 26, 27, 31,
So, yes, I, sir.
31, 35, 36, 53. So these are the absent roll numbers.
Sir, 64 पर्यंत sir last.
64 केला count आला तो 64.
आणि 36 पण present.
36 present आहे. कुठे 36? Please raise your hand. हा ओके. ज्ञानेश्वर कुंभार.
सर आपलं वेन कॉम्प्रेसर राहिलंय का घ्यायचं?
घेतलाय वाटतं मी. फक्त मी लिंक अपलोड
No, sir.
केलेली नाही तिथं.
Sir, 33 present.
हा ओके. 33 आहे प्रेझेंट. मी कॉम्प्रेसर पर्यंत आलो होतो. दुसऱ्या 2 डिव्हिजन तुमच्यापेक्षा पुढे होत्या 2 लेक्चर. त्यांचे टर्बाईन झालेले आहेत, तुमचे टर्बाईन राहिले होते. कारण आता गुरुवारपासून गुरुवार, शुक्रवार, शनिवार हे 3 दिवस त्या 2 डिव्हिजन वरती लेक्चर असतात मला, आणि सोमवार, मंगळवार, बुधवार तुमच्या डिव्हिजन वरती असतात. आणि जरी राहिला असला तरी काय अडचण नाही, आपण घेऊ. आता ऑनलाईन असल्यामुळे एवढी काय अडचण नाही. ओके, टाइम टेबल पेक्षा जादा लेक्चर
ठीक
घेऊन आपण घेऊ शकतो, कव्हर करू शकतो. ठीक आहे. तुम्हाला समजलं नसेल
Okay,
एखादा
sir.
तरी पण आपण सिलेबस झाल्यानंतर किंवा चॅप्टर झाल्यानंतर एखादा पॉईंट समजला नसेल तरी रिपीट घेऊ एखादा, काही अडचण नाही त्याची. Okay. पण तसं बघायला
Okay.
गेलं तर चॅप्टर खूप सिम्पल आहे, कन्स्ट्रक्शन वर्किंग आहे, पण सोपं आहे म्हणून बऱ्याच वेळेला मुलं काय करतात, दुर्लक्ष करतात आणि याचे मार्क सगळे निघून जातात. तर त्याच्यापेक्षा याचा चांगला अभ्यास करा. हे सोपं जे आहे त्याचे पूर्ण मार्क आपल्याला मिळाले पाहिजे. ओके. Okay, with this we will stop here. I will upload link.
Sir.
Yes. Yes,
सर
Raj.
काल लेक्चर मध्ये मी प्रेझेंट होतो, पण नेटवर्क इश्यू मुळे माझा ऑडिओ तुमच्यापर्यंत पोहोचत नव्हता. मग कालची अब्सेंटी लागली माझी.
तुम्ही ह्याच्यामध्ये टाकलं होतं ना पण चॅट बॉक्स मध्ये
तेवढ्यात मीटिंग सर ही झाली, तेवढ्यात क्लोज झाली.
क्लोज झाली का? 54 ना?
नाही सर, 38.
38. ओके, ठीक आहे, मी बघतो, लावतो तुम्ही चॅट. ठीक आहे. तर मी आज एमसीक्यू अपलोड करतो, म्हणजे तुम्हाला असाइनमेंट कंप्लीट करायला अडचण येणार नाही. ओके. ओके, विथ दिस वी विल स्टॉप हिअर. आपण थांबूया तिथे.
सर,
हा,
आतापर्यंत झालेले डायग्राम काढायच्यात काय? इथून पुढे जे पॉइंट कव्हर होतील ते पण डायग्राम काढायचे?
आतापर्यंत जेवढ्या झाल्यात त्या कपलान टर्बाईन पर्यंत, म्हणजे पुढचा एक टर्बाईन आहे तिथपर्यंतच्या सगळ्या डायग्राम काढायच्या. प्रत्येक डिव्हाइसची एक डायग्राम येणार, म्हणजे सेंट्रिफ्युगल पंप म्हणतं की त्याची एक डायग्राम, बरोबर आहे. फ्रान्सिस टर्बाईन म्हणलं की त्याची एक डायग्राम. अशा सगळ्यांच्या डायग्राम एका खाली एक काढायच्या आणि त्याला नावं द्यायची. फक्त त्याचं काही लिहायचं नाही एक्सप्लेनेशनच्या ऐवजी आपण एमसीक्यू
लेबल करायचं ना सर?
हा, लेबल करायची. पूर्ण डायग्राम काढायचे आणि त्याला लेबल्स करायचे. कन्स्ट्रक्शन त्याचं नाव द्यायचे सगळं पार्ट. ओके. Okay, I hope you all have understood. So with this, we will stop here for today.